Hi BotConf, and thank you for listening to our presentation from the comfort of your home. Today we're presenting about APKatche Me If You Can, uncovering obfuscation as a service for malicious Android applications. This presentation is the result of a partnership with Vit Sambera from Trend Micro, myself, Masara Paquet-Clouston from GoSecure, as well as Maria Jose Erguiaga and Sebastian Garcia from the Stratosphere Laboratory. Today we're presenting the results of a unique opportunity we faced while being confined at home during the first wave of the COVID pandemic, and this was related to investigating an obfuscation as a service platform for Android applications. We felt this was a unique opportunity to be able to uncover the service usage, its efficiency, its obfuscation technique, how efficient it is, and the like. The presentation today is divided in 3 sections. The first one is about the story, so how we uncovered the platform and what was our strategy to investigate it. Then we'll go over the reverse engineering results, so what were the obfuscation techniques. And lastly, the third part is about service usage, efficiency, and potential profitability, which basically provides a better understanding of the context in which the operators behind the platform operate. So let's start with the story. It all started when the Stratosphere Laboratory and myself partnered together, and they shared to me the chat log containing discussions among operators of an Android banking botnet duped Just, and we wanted to work together and try to understand better what were the motivations behind the actors contributing to the Android banking botnet. And while we were doing this, we ended up encountering an interesting conversation where one of the operator mentioned, "Do you remember the link for the crypt?" And crypt is kind of a bad translation from Russian. You say crypting, obfuscating, or protection, and then a person shared the link. We're not putting the link in clear here just because we don't want to tip off the administrators that we found or that we've stripped naked their service. But if you want to, or if any malware analyst wants to go and deep dive, you can do a ROT13 of this link and you'll find the true link of the service. However, it's down right now. So seeing this link, what we ended up doing is go on the platform, and we ended up seeing that you could log in or register and then potentially obfuscate or crypt applications. Notice that it says protect, so it doesn't say obfuscate, so protect against antivirus detection in this case. And to be able to register, you need to have a code. So we couldn't do it right away, creating barriers of entry for curious individuals like us. However, luckily for us, we had access to Flare's systems in 6GIL, 2 darknet monitoring platforms, from which we searched for the platform, and we ended up finding lots of ads where the administrators of this platform were actually advertising their service, encouraging people to register. So here we give you an example of one ad that was on Hack Forums, and as you can see, it says automated service for the protection of Android applications, and there's a coupon code available in the advertisement, which allowed us to log in the service. Here we just give you the prices, but we could go and see, how to obfuscate APKs. You could upload them automatically once your balance was updated and do it without having to talk to the administrators of the platform. As you can see in the prices, it's quite expensive, $20 for 1 APK or $100 for 10 APKs. And if you wanted to obfuscate many APKs, you could use 30 days unlimited access with an API for $850. So we thought we had a unique opportunity. Obfuscate APKs and compare the obfuscated version with the non-obfuscated one. However, we knew that the GIOS.NET operators had used the obfuscation service, and we knew that the GIOS APKs were heavily obfuscated because Vit Sambera for Trend Micro had already reverse engineered GIOS APKs and published on them on a Trend Micro blog. So we thought it'd be interesting to ask Vit if he'd want to join the project because he had already lots of knowledge on the obfuscation techniques that were used, and luckily for us, he accepted. So we've been together, working together ever since. The first thing we did is an automated analysis using MobSF. So we compare the results from the original file and the obfuscated file. Basically notice first that the CVSS score is different for the original file and the obfuscated one, which means that the obfuscation worked at hiding the vulnerabilities found in the original file, which resulted in an increase in the security score for the obfuscated file. Notice also that the package name and main activity changed. So for the original file, it's normal words, whereas for the obfuscated one, it's long random strings, which may look more malicious for a malware analyst. And lastly, we want you to see that activities and number of services changed. So for the original file, the number of activities was 2, and for the obfuscated one, 10, which shows that the obfuscated file seems to be more complex. And then the number of services for the original file went from 1 to 3, illustrating that the obfuscated file may have more tasks running in the background, which may look more suspicious. So overall, we think that based on this data, the obfuscated file seems more malicious than the original file. But let's look now at the results of the reverse engineering of the obfuscated application with VIT.
Hello everyone. Now I will share some details about the obfuscated sample of log APK. There will be a few examples of the code extracted from analyzed sample, and you don't need to read them in detail. They are mentioned for illustration purposes only. After the compilation of classes dex file, there are hundreds of similar classes like you see on the slide. Symbol obfuscation can be expected. Here are randomly generated strings of length 6 to 12 characters. But what is this green garbage stored in string variables? Can it be some kind of encoding? I have tried frequency analysis, entropy analysis, but this gave me no clue. And no reasonable Java code can be found in those classes. Few classes contain something like this. It is a Java code, but it does not make much sense. As it was discovered lately, that code marked by red boxes is a junk code inserted to make reading difficult. You can find Boolean, integer, string variables assigned with randomly generated literals, and also if then else, switch case and try and catch construction, go to jumps, and even randomly edit methods and method parameters. And here is another example using switch command. As you can see, understanding of such code is difficult. Here are tools I have used for analysis. Injected junk code made the compilation task difficult, even for all well-known Java decompilers. Especially nested exception blocks in combination with goto instructions were very hard obstacles for them. So final decompiled code had to be combined together from different tool outputs. Best results gave me JEP decompiler, which is a commercial product. On the opposite side was Ghidra decompiler, which has been struggling even with simple parts of code. Manual Smalley to Java decompilation has been used in few cases because all decompilers failed in this task. There is still a space for improvement, mainly for open source Java decompilation tools. Python interpreter is mentioned here as it has been used for byte array to strings decryption. When digging through heaps of nonsense code, this piece draws my attention. It looked quite familiar to me. Can it be a piece of RC4 code? After symbol obfuscation and junk code removal, the same method looks like this. Here are corresponding parts of code. The RC4 algorithm has been split by authors between several methods to make itself less recognizable. Here are some of them. Most important for us is this method containing an encryption key. When RC4 decryption method has been revealed, it was clear there is a lot of byte arrays encrypted with RC4 algorithm. They are used as a string constructor argument. Here is one example in original code. The reason is that Java deflection library methods are used, and names of methods and their parameters needs to be hidden. Otherwise, it would be too obvious what the code is doing. So I did a small Python program for decryption of those byte arrays. Then I replaced decryption method calling by resulted strings directly in the source code. And here is the same code after string decryption and code cleanup. After junk code removal, strings decryption, reflection methods named the obfuscation, we could guess what could be other methods doing and what could be their names before obfuscation. Here is the core of the APK executable code. I will shortly describe what this method is doing. There is a file stored in the APK. This method opens the file, decrypts it using the same RC4 algorithm and key as strings before, saves it with a different name, and then loads it as a DEX module, and finally deletes both files. And the locker is loaded and activated now. So this code played a role of a Trojan horse for a malicious Android application. When looking into APK, you can find a directory named tracks. It contains several files with randomly generated names. I did not analyze their contents, but they are not used in the code, so it doesn't really matter. The only important file is the radio awk, which contains encrypted second stage DEX file. And here we have the resulting locker code after decryption and decompilation. The only obfuscation method used in second stage is symbol name obfuscation for symbols which are referenced in the manifest file. In comparison, Geos did also encrypted strings even in the second stage. I'm not sure if it's a joke or attempt to distract attention of the analyst, but there has been always part of code with unobfuscated and attractive symbol names, but always in a part of code which is never executed. This is an example of SQL-like code. So, the result of the analysis is the Java code is a dropper trojanizing malicious Android application. It is heavily obfuscated, and the only task it has is to decrypt second stage DEX file and launch it. It is difficult to perform automated analysis of the dropper, but it's not impossible. To decompile second stage, you need to find a class with RC4 algorithm within hundreds of junk code classes. Then you have to recognize a method containing RC4 key. Hint is, the key byte array is assigned to a byte array variable. The rest of byte arrays are used in place of the string constructor parameter. A key has been different in each analyzed sample. Then you can decrypt and decompile the second stage file embedded in the APK. Be careful, dropper code is evolving. In earlier versions, a file carrying second stage contained only the encrypted DEX file. In later version, a simple header containing the length of the file encoded in 4 bytes has been added. Side effect of this kind of obfuscation was increase in size of the original APK about 32 times, mainly due to inserted junk code. And this is all from short overview about analyzing such sample. Total time needed to complete the obfuscation of first jailed sample was about 3 weeks, but consecutive analysis has been done in about an hour.
Okay, so I'm back for the service usage, efficiency, and potential profitability, the third part of our presentation. So let's start with service usage. We wanted to know whether or not the obfuscation service was used by a lot of actors. So the first question we asked was, are there files currently submitted on VirusTotal that are APKs, zip, or jar with radio.org file? And luckily for us, there were about 3,057 APKs that fitted this fingerprint. So just to validate that we didn't find any false positive, we decompiled all applications and automatically fetched information from them. And we noticed that all manifest files had package name, main activity, activity, and service names that were long random strings, just like in our own obfuscated APKs. And we also noticed that the radio.org file for all APKs was stored in the tracks folder. So this kind of allowed us to conclude with great confidence that the APKs we found were related to the obfuscation service. So here we give you a plot through time from May 2020 to October 2020 on the number of applications that have been submitted on VirusTotal. The flat line in between that you can see in the graph is basically just the pause in between the two retro hunt jobs that we did. What you can see is that there's files that are being submitted daily on VirusTotal that are related to the obfuscation service. The other question we had was, well, based on this, are all APKs found on VirusTotal from the same group? And I ended up investigating and taking quite a lot of time trying to cluster these APKs together without having any results. For example, clustering the number of permissions, the kind of permissions, or the, let's say, the tags that were given by antivirus engines without any results. However, I didn't give up and I continued, and I ended up finding something quite interesting. In the res values folders of the obfuscated applications, there was leaked information, especially in the strings.xml and the IDS.xml files. So here I give you an example. For example, you see that the string names in the string.xml file here is obfuscated, so like it's random strings. But you notice as well that the string is not, so it's in clear, it says Adobe Flash Player. So basically from this finding, we could group APKs together based on if they had the same first strings in strings.xml, or if they had the same structure in IDS.xml, or both. And this yielded interesting results. We found 7 groups that had the same strings.xml or IDS.xml, and these groups were quite different. So what I did to analyze them and see whether or not the APKs within each group were similar is I took a dozen of them from each group and inputted them in the APKlab.io tool, which is a tool developed by Avast that does dynamic analysis of applications. And what I noticed is that most of the APKs from each group behave the same way and connected to similar domains, or the same domains. So for example here, group 1, APKs were faked as Flash Player and Instagram shared, and they all the APKs I investigated communicated with DNS address right here. Another example is the group 4. All samples, like all the APKs that I inputted in APKlab.io, like communicated with the domain hackathon.ru, which is known to be, which seems to be related to the FlexNet malware, helping me to confirm that it was most likely the same group and that the grouping was accurate. You notice also maybe that group 2, 3, and 6 all have Turkish names, like in their name of APK. We could have concluded that it was the same group who were targeting Russian citizens, but it was hard for us to do that just because these 3 groups, they didn't connect to the same domains and they didn't behave the same way based on the dozens of applications that I investigated from each group. So from that, we decided to keep them separate because we didn't know if it was the same group or not, even though there was Turkish in the application's name. Lastly, we had others, so about 60 APKs we couldn't group. And luckily for us, we also found our Android lockers, adware, and SMS stealer in the data as well. So let's look at service efficiency. Our question was, are the obfuscated APKs found on VirusTotal detected by antiviruses? And our response was yes. We took 2 strategies. We looked first at our obfuscated APKs and compared them with the original ones. And then we also looked at the APKs we found on VirusTotal, our sample of about 3,000 APKs, and asked us whether or not these APKs were detected. So let's look at our own files for now. So look here, you can see that for the Android Locker and the SMS Stealer, our 2 highly malicious applications, the number of detection decreased. However, for the adware APK, so the less malicious one, the number of detection increased. So this made us wonder. We wonder if this was an outlier, and we wanted to test whether or not a binning APK with no detection would see a detection rate increase with the obfuscation. So what we did is we obfuscated a Hello World APK, and that APK, once obfuscated, went from 0 detection all the way up to 8. So that confirmed that the obfuscation service could be interesting for actors who have highly malicious applications, because the obfuscation service would then decrease the detection rate of these applications. But if somebody had a binning APK or an APK that wasn't detected, then using the obfuscation service would not be efficient because they would see their detection increase. We then looked at our sample on VirusTotal, the 3,000 APKs. Here we give you the distribution of the number of detections for the whole sample. And what you can see is that they were all minimally detected by at least 8 antiviruses. Then we wonder if this was different in terms of groups. So we plotted the number of detections based on each group. And we also computed a series of tests on mean differences, and we found that there was significant mean differences in each groups. So some groups were more detected than others, thus giving more confirmation to our idea that these were different types of APKs as well. And lastly, we looked at the service potential revenue. Our question was, considering the obfuscated APKs found on VirusTotal, approximately how much have the platform administrator made with them? So we took the prices that we found on the platform, and we developed two strategies. The first strategy was for all groups with hundreds of APKs scattered through time, we considered they bought an API price of $850 a month, and for the remaining groups, we considered that the highest price of $20 per APK. And that yielded the results of all the APKs found on VirusTotal. The administrators would have made $22,490. Then our second strategy was to not consider the groups and rather consider the highest and the lowest price for each APK found on VirusTotal. And here we give you the potential cumulative revenue in US. And what you can see, if it was only one group obfuscating APKs within these 6 months of investigation, the operators would have made $5,000. And if it was all APKs that were paid at the highest price of $20 per APK, the operators would have made $61,000. So the first strategy yields a lower bound, so a little bit less than the middle between the two interval. And we think this is probably a better or a more accurate estimation of the profit or the revenue that these individuals made. Is $22,490 a lot? It probably depends on where the operators are hosted and located in the world. So if it's in a low-income country, it might be really interesting. If it's a high-income country, then this wouldn't represent a high salary. Lastly, we looked at the competitors using the 6GIL and Flare Systems platforms. I ended up finding 6 competitors advertising during the year 2020 on different underground forums for obfuscation as a service for Android applications. Notice forums like XSS, Dark Market, Hack Forums. And notice as well that the prices are slightly higher than the one that we investigated. None of these competitors offered a platform with an API, and all of them said that purchases happen via private message on Jabber or Telegram. So our hypothesis is that these competitors are probably doing manual obfuscation, thus the higher prices, and the one that we investigated was offering an API and automatic obfuscation, which could have been a competitive edge in the market. In conclusion, we believe that the service we investigated is a medium quality obfuscation service. A lot of work has been put in automating the process, but that also makes it easier to fingerprint. We believe that the clientele for the service are individuals developing highly malicious applications, so these individuals would want to see the obfuscated version have lower detection rates, thus potentially increasing their infection rate. And we wanted to mention that the platform has been offline since August 2020, yet we still see APKs being submitted on VirusTotal as of November 2020. So either these APKs are just APKs that were obfuscated before and still caught in the wild, or the administrators are still active without the platform, so without accepting new clients potentially. And we wanted to say props to the good job done by the security community in the past years, because definitely it's not that easy to create an automated obfuscation as a service. So we wanted to say good job, because sharing the data as we have been doing in the past years works. So we also wanted to mention that there'll be upcoming blogs and data sharing during BotConf. So if you're interested in digging further, there'll be more details in each of them, and they will be available on each of our websites. So thank you, BotConf, and we'll be here if you have any questions.